I want to welcome our first speaker. He's joining from Japan. So I asked him, and it's already 8 p.m. for him. Thank you, Kenji Kazumura. He's a senior architect of Java technology at Fujitsu. He is the enterprise member representative at Adoptium Steering Committee. Today, Kenji will join. He will explain how cloud-native sandboxing with seccomp and AppArmor is security in the Java software supply chain using Adoptium technologies. So we will learn about that, and he will provide some practical application on this performance on how to use Adoptium projects. Over to you, Kenji, and thank you.
Okay. Hello, everyone. Thank you for joining me today at the Adoptium Summit. I'm Kenji Kazumura from Fujitsu, and today we are going to dive into cloud-native sandboxing with seccomp and AppArmor. We will discuss how these technologies can help us secure the Java software supply chain cooperating with Adoptium technology. Today's agenda. We'll start by setting the context, discussing the challenge of securing the software supply chain in the Java world. Then we will dive into sandboxing technology. Finally, we summarize the key takeaways. Before starting, a little bit myself. I serve as some members of several Java-related groups or committees, including Adoptium Working Group and JCP Executive Committee. And I'm also working for Fujitsu as a Java architect, and Fujitsu provides several Java-related products, which include Fujitsu own build OpenJDK, and some of Adoptium technology has been implemented in the Fujitsu build OpenJDK. So let's get started with the first topic, the intersection of Java and software supply chain. I think most of you know well about software supply chain, so I am going to talk briefly. As you can see, the security threat can emerge at any step of developing process, like coding, building, packaging, and so on. So because of that, in the worst case, bad package, which include malicious code, are spread in the world. So we need to do something to protect our chains. At Adoptium, we are aware of these challenges. The Temurin project has made a significant effort to provide a trusted JDK. This includes using reproducible build to ensure binary are consistent and verifiable, providing the S1 software bill of material for transparency, and so on. So these efforts have led to Temurin project achieving SALSA level 3. So we are doing good jobs. So with the trusted JDK, is our work done? You have your Java application running on a trusted JDK, which runs on the host operating system. So this clean separation seems to suggest you can now focus only on your application business logic. But in the real world, picture is far more complex. Our applications are built upon a vast ecosystem, including untrusted third-party dependencies, like here. And furthermore, with the dangerous features like JNI or FFM, which is foreign function memory. untrusted Java code can interact directly with native library by passing the trusted JDK. So each of these untrusted dependency has the potential risk to be attacked by an attacker. So it is important to recognize these vulnerabilities within the ecosystem. So how do we manage the risk from these dependencies? There may be several ways, and plan A would be to fork and audit every single library we use. But as you can imagine, this is practically impossible for any non-trivial application. So this leads us to plan B. We accept the fact that we cannot fully understand the behavior of third-party library. Instead, we focus on controlling their behavior from the outside. We place them in sandbox to limit what they can do, ensuring they only perform safe actions. Well, that is a sandbox. And I think as you may know, Java has a long history with sandboxing through the security manager. It was originally designed to contain untrusted applet running in a web browser by restricting what the code can do. But as industries shifted to server-side Java, people likely think that you are running trusted code on the server side. So the primary threat was no longer untrusted code. This is one of the reasons why Java Security Manager has been deprecated. But look at this table. This is a research paper published by CMU. This research itself is a little bit old, but this is a list of the OSS which use Java Security Manager. It shows that the Security Manager was used by some of major server-side OSS. And speaking of the OSS, we often feel that OSS is trustworthy because its code is open for anyone to inspect. But as the recent XD backdoor incident proved, transparency does not automatically equal trust. These comics perfectly illustrate OSS dependency problems. We simply cannot blindly trust all our dependencies. So now we have learned that we need some sandboxes, but Java Security Manager was already deprecated in the recent JDK. So the question is, how do we build the next generation of sandboxes? For the reference, we look into the container approach. The Linux provides the combination of several mechanisms to protect the container process. For our discussion today, we are going to focus on two key security technologies related with sandbox, that is AppArmor and seccomp. Seccomp stands for Secure Computing Mode, and both seccomp and AppArmor are Linux kernel modules. And they are widely used by container runtime, like Docker and Kubernetes, to build sandboxes. Seccomp job is to control which system call a process can make. And AppArmor, the job is control access the resources like file or network socket. Okay, let's look at the detail of the seccomp. This is a flow of seccomp. There is a process running on the user space, and this process make attempt to call a system call like read or write. And seccomp intercepts this system call before it reaches the kernel. And based on the predefined policy or rule, seccomp decide whether to allow the call or to disallow the call. This is a very simple flow, but one important thing that you need to keep in mind is that you can filter system calls based on their parameter values. But this really works only for argument passed by value. For argument passed by reference, like a file name string, seccomp only sees the address in the user space, like 0x1234. So seccomp cannot see the actual file name, like foo.txt. Because of that, it is difficult to filter a system call based on file name by seccomp. So you can configure several actions to seccomp. For example, act kill process means terminate the process if violation of the rule. And act error number calls the system call to fail with an error code. And act log allows the call but logs it. And this action is very useful when you are trying to create a whitelist profile for your application. And using the seccomp with Docker is very easy. Of course, seccomp works in non-Docker environment too, but I will use Docker environment for today because it is very easy to use. This is the example of the configuration file for the seccomp. You define your policy or rule in JSON file. In this example, we are allowing all system call by default in this line. And we create a specific exception for write system call, make it return an error with this action. And then you just apply this policy at runtime using with this security opt flag. Okay, let's see a demo of seccomp with Java. At first, I'm starting a Docker container with Temlin 24 image. So JShell is the default entry point of Java container. So please notice that we haven't applied any security rules yet. So this is the normal behavior. I'm executing a simple piece of Java code to create a new directory, like temp, abc, and mkdir. This is Java code. And result is true as expected. So that means that we can successfully create the temp directory and make sure to see the list of temp here. And yeah, there is ABC directory for sure. So this is a normal behavior, nothing special, nothing interesting. Next, let's use the seccomp profile to restrict this behavior. This is the profile, seccomp profile to restrict this behavior. Again, default action is seccomp allow. That means we allow all system call by default. And this is a specific exception for mkdir system call. And action is seccomp at error number. That means when we call mkdir system call, seccomp just returns an error. And let's run the container again. In this time, I add this option, security opt and seccomp equal mkdir JSON. And again, JSL. In this time, I'm executing exactly same code as before. And go here. And in this time, the result is false. And make sure the list of temp directory. So there's no ABC directory. So Java mkdir method of file class call finally mkdir OS system call. And seccomp intercepted this mkdir system call, and as we instructed here, the kernel returned an error. And then JVM translate into this false value as a result of mkdir method. So this is a seccomp, and it is very easy to use. But the problem of seccomp is it can restrict only OS system code. So this demo is very easy. You can imagine the relationship between Java mkdir method and OS mkdir system code. But in general, it's extremely difficult for Java programmers to know the corresponding between Java API and OS system calls. Moreover, Java API and OS system call do not typically have one-to-one mapping. So because of this, the way I recommend for using seccomp is create a whitelist. At first, create a whitelist of system call by running your application using seccomp with log action in a secure environment you send. Then, in the production environment, reject any system call not on the whitelist. This is one of the use case of seccomp from the viewpoint of Java developers. Okay, let's move on the AppArmor. AppArmor is almost same as seccomp, but it's focused on controlling access to the resources rather than the system calls. You can define the rules for files, directory, and socket, and signal, and so on. This is the mechanism of AppArmor, and it is very similar to seccomp. But before using AppArmor, you need to use AppArmor parser command to load profile into the kernel. Profile is a set of rules you define. After that, process makes attempt to access some resources like foo or bar. AppArmor intercepts this access, and it checks the profile rule and decide either allow the operation or block it. AppArmor offers two modes of operation. Actually, there are more modes, but mainly these two modes are used. One is enforce mode. This is the default mode, and where the profile rules are all applied in enforce mode. And another one is complaint mode. In this mode, no action are blocked, but any violation of the policy is just blocked. This mode is very useful when creating a whitelist. And using AppArmor with Docker is also very easy. Again, AppArmor also can be used in non-Docker environment, but again, I use Docker environment in the demo. Here is an example of profile. There's some boilerplate code, but the name here is the name of the profile. And this part is a specific rule to deny the access to specific directory. And just like with the seccomp, you attach this profile with the security option like this. Okay, let's move on the AppArmor demo. This is a profile I prepared. And the name of this profile is mkda-java. And there is some boilerplate, but the important part is here. We create a special rule to deny these resources, temp ABC. And before using AppArmor, we need to register this profile to the kernel. But I have already registered this profile. So make sure with AA status command. And here, mkda Java profile is in enforce mode. Okay. Now, let's run the same Docker container. In this time, I add this flag, security opt AppArmor equal mkda Java profile. And again, JSL, and I'm executing the same code as before. Then ABC and MK here. So in this time, the result is false because this resources match this rule. And try another one. For example, XYZ. In this time, the result is true because this resource does not match this rule. And make sure the list of temp directory. So we see only XYZ directory, but not ABC directory. So I think for the Java developers, AppArmor is easier to use than seccomp because the resource names are intuitive for Java programmers. Okay, next, seccomp again, but in this time, it is a little bit different from before. As I mentioned before, standard seccomp isn't inspect argument passed by reference like file name. There is an advanced feature called seccomp notify that may solve this problem. It allows the kernel to pause a system call and delegate the allow deny decision to a helper or filter program running in the user space. The filter program then inspects the calling process memory to read the file name and make a more informed decision. But the trade-off is that you are now responsible for creating and running this filter program. So this is a flow of seccomp notify. A process makes a system call, and seccomp intercept this call and send a notification to the filter program running in the user space with the parameters. And this program, filter program, investigate the parameters and make a decision and back the decision to the kernel. And the call is approved. If the call is approved, the kernel proceeds to execute it. And how does the filter program analyze the parameters? This picture is a little bit complicated, but the point is here, step 3, the notification from the seccomp include process ID or parameter value. In this case, the memory address in the user space, 0x1234. And filter program use these information to analyze the target process in the user space. In this time, filter program read the memory address 0x1234 and get the actual file name. And this program uses this information to make a decision. Okay. So I'm sorry, but today I'm not going to talk how to create filter program. But traditionally, you require to use C programming language for creating the filter program because seccomp provide only low-level interface. But thanks to the new foreign function and memory API, FMM, in modern Java, we can now write this kind of system-level code in pure Java. So let's move on the seccomp notify them. At first, let's quickly look at the handler code. This is the Java code using FMM. And I don't explain the whole of the program, but there are just 2 points in this time. The one is here. This is the socket name, which is used for the communication with the CAN. And another one is here. Here is a policy logic or filtering rule. This means you need to write your own logic in handler code by yourself. I created a very simple one for this demo. It inspects the path provided to the mkdir system call. If the path is exactly same as temp xyz, it will deny the request. But for any other path, it will allow. This is the handler code. And mkdir. This is a configuration file we pass to the Docker runtime. It is almost same as the previous one I used. The difference is here, I changed the action from sect_act error number to act notify. That means that this kernel not to decide on its own, but to send a notification to the filter program through this listener socket. This socket name must be the exactly same as the one used in the handler code. Okay, let's start the handler code. This is Java code. And again, I start the container. With the security option. JSL again, but you can see some notification is already get by the handler because JVM creates some directory during the initialization, but there is no problem. Okay. So I execute the same Java code like ABC and MK here. So in this time, the response is true, and the handler also received the notification of this system call and return the OK response. And try another one, XYD. This will be blocked. And the result is false. And handler logged the this call and return the NG response. And make sure the list of temp directory. So only we can see ABC directory, but not XYZ. Okay, we've covered some sandbox technology. Now let's bring it all together. This table provides a high-level comparison. Java Security Manager offers a powerful feature, but it's a little bit complicated. And most important thing is Java Security Manager has deprecated. And seccomp, standard seccomp is very simple, but it cannot inspect resource paths. And seccomp notify provides the most granular control, but you need to implement filter program by yourself. So there is no single best answer. The right choice depends on your security requirement and your skills. To wrap up, securing the software supply chain is one of the most critical challenges in software development today. The Adoptium provides several technologies to make a trusted JDK, but it is not sufficient on its own when you create the whole Java system. I introduced today some sandboxes. Of course, sandboxing technology does not solve everything, but using this technology like seccomp and AppArmor may mitigate the risks. If you are interested in this technology, please give them a try. So that concludes my presentation. Thank you very much for your time and attention.
Thank you, Kenji. We have a question. Actually, we have two questions from the attendees. The first one is seccomp specific to Linux or it is available on BSD too?
I think it is only available Linux because seccomp and AppArmor is a Linux kernel module.
Thank you. And the second one is, I guess Java module system also provide a kind of sandboxing?
Mm.
Yes.
Yes, Java provide security manager was provided security manager, but it's deprecated since I remember maybe Java 17 or around that. So in near future, you cannot use the security manager as the sandbox, a native Java sandbox. So we need to find another way to use sandbox with Java environment.
Okay. Thank you, Kenji, for your time, for your presentation. And